multi-step equations. So we talked about solving two-step equations. Solving multi-step equations is really similar. We just want to get x completely by itself. That's the entire goal, to figure out what x equals. And the way we're going to do this is by using the distributive property and combine all like terms on one side of the equation, and then it's just going to turn into a two-step equation. Then we'll use our inverse operations to isolate the variable. We're undoing order of operations. Remember, we're just working order of operations backwards by using inverse operations to isolate the variable or get the variable by itself. And you can also always check your answer to make sure that you're doing these correctly. Alright, so like I said, we are always going to distribute and combine like terms as our first step. So here we can distribute twice. We have this 2 that is sitting outside the parentheses here. The 2 gets distributed into the parentheses, 2 times x, and 2 times 3. Remember, that's multiplication. So the negative 28 is just going to come down. We do 2 times x, that becomes 2x, and 2 times a positive 3, that becomes a positive 6. We can distribute here also. That minus sign is a part of that 5. We're distributing a negative 5 into both of these. Negative 5 times 1x becomes negative 5x. Remember, when you get a negative sign from that, it becomes subtraction when you write it in that next line. That's negative 5x, so we write it as minus 5x. And then negative 5 times negative 1. Again, the subtraction sign is a part of that number. That's really a negative 1 that we're multiplying by a negative 5. A negative times a negative gives us a positive. Since that's a positive 5, I'm going to write that as a plus 5 in my next line. Whatever sign you get from that multiplication, that's the sign that you write with the number. It's a positive, so we write a plus sign. So this is going to be a pretty common pattern. We distribute first, then we combine like terms. So we distributed everything that we could. Now we're going to combine like terms. 2x minus 5x. We're using the sign that's directly in front of that number. 2 minus 5. That combines to make negative 3x. 6 plus 5 gives us 11. And the left side just comes down. That becomes negative 28 equals negative 3x plus 11. This is now a two-step equation. So now we can go with that box method. We box our x term, and we're going to deal with the thing on the outside of that box. So we're going to try to cancel out this plus 11. We're going to do that by subtracting 11 from both sides. So that gives us negative 39. It's negative 28 minus 11. That gives us negative 39. The negative 3x comes down. The positive 11 and negative 11 cancel each other out. Then we have one more step. This right now is multiplication. That's negative 3. That's being multiplied by x. We're canceling out that operation by using the opposite operation, or the inverse operation. It's not the inverse of that number. It's not the opposite of that number. It's not a positive 3. It's the opposite of the operation. That's multiplication, so we use division. Divide by that exact number to cancel that out. It gives us 13, positive 13 equals x, or x equals 13. We're going to check our answer here. We're going to take that x value and substitute it back in place of these x's. So we're going to rewrite this whole equation. Negative 28 equals 2 times, in place of that x, I'm putting 13 in parentheses. So all I did was rewrite this, but in place of that x, I put 13, and each time I did that, I put that in parentheses. Now we can do order of operations by hand here, but since we have Desmos, we might as well use it. So instead of actually doing it this way, I'm just going to write exactly what I see here. So again, if you want to, you can solve this using order of operations. You do inside the parentheses first, then the multiplication, then the subtraction. I don't think that's the easiest way, so that's not what I'm going to show you here. I'm going to show you that you can type this exact same thing, exactly what you see with those letters, into Desmos, and then in the next line, you just tell it that x equals 13. And then it'll do that substitution for you. 2 times x plus 3 minus 5 times x minus 1. It doesn't know what x equals yet, so you have to say x equals 13. And then it does a substitution for you and tells you that that whole expression, when x equals 13, that whole expression equals negative 28. And that's exactly what we're looking for. That is negative 28. When I plug in 13, that also equals negative 28. So I did that correctly. You want to just make sure that you get the same thing on both sides of the equal sign. All right, so same kind of steps. Distribute first, then combine like terms. So I'm going to draw that line down the equal sign just to make sure that if I do something on one side, I also do it on the other side. So that's only if I change something on this side. Distributing isn't really changing anything. It's just simplifying what I have on this side. So I'm going to distribute here. Negative 2 gets distributed into this side. Again, that sign is a part of that number. Negative 2 times 4x is negative 8x. This negative 21 is not used. You might have the impulse to subtract these two, but you can't do the subtraction until you do multiplication. To simplify, you're following order of operations, so you have to multiply before you do any subtraction. That's why we have to distribute first, then combine like terms. Distributing is multiplying, combining like terms is adding and subtracting. So the negative 21 is just going to come down. This multiplication became negative 8x. Negative 2 times positive 3. That is negative 6. So in that next line, I'm going to write minus 6. So I distributed. I multiplied first. Now I'm going to combine like terms. Negative 21 minus 6. Negative 21 minus 6 is negative 27. You could put that at the front or at the back of this expression. The equal sign and the negative 67, those are going to stay the same. I'm going to put it second. I'm going to put the negative 8x first. And then minus 27. If you wrote it like this, negative 27 minus 8x equals negative 67. That's also correct. As long as the signs don't change, that's a negative, that's a negative. Same thing here. Those are both negative. Doesn't really change anything. Now I can box my term with the x on it and deal with the one that's outside of that box. Here is where I'm doing my first step to actually change this equation. I'm adding 27 to both sides of that equal sign. So the minus 27 and plus 27 cancel each other out. We get negative 8x equals, that gives us negative 40. One last step. This is multiplication. To cancel out multiplying, do the opposite operation, or division. So divide by negative 8, that gives us x equals negative 40 divided by negative 8 is a positive 5. Again, if you'd like, you can check your answer. You type this whole thing into Desmos, then say, I think x equals 5, and see if you get negative 67 as your answer. All right, on number 3, we see some fractions, which might be overwhelming. If you want to change that into a decimal, you can. Actually, let's do that. Let's just divide these. 1 divided by 2 is 0.5. 3 divided by 2 is 1.5. I don't see any distributive property. I don't have a number that's outside the parentheses like that. So I'm just going to skip to combining like terms. I'm going to put these two together. Remember, that's all just working on one side of the equal sign. So I don't have to do anything on both sides. I'm just putting these two together. And then separately, I'm going to put these two together. So it gives me 0 equals 0.5 plus 1.5 would just give me 2, so that becomes 2x. Remember, if it started with an x, it has to keep that x. We're just adding those two together. That becomes that new number in front of the x. So we have 2x minus 21. It's negative 15 minus 6. That's negative 21. That becomes minus 21 in the next line. Now I can start solving it. I'm going to box my x term and cancel out that minus 21 by adding 21 to both sides. One last step, that's multiplication, canceling multiplying by dividing. So that gives me 10.5 equals x. In general, if the question gives you a fraction, it's probably going to expect the answer as a fraction too, so I'm just going to rewrite this as a fraction. Actually, you could write it as an improper fraction like that, or as a mixed number. I'm going to write it as 10 and a half. All right, number 4, again, we have a fraction. It doesn't really change any of our steps. We want to distribute first, then combine like terms, then start solving. So I'm going to distribute first, 2/3 times x, 2/3 times -9. It does not get multiplied into that. That's not in the parentheses. So that's just going to come down. Anything that's not affected by the distributing just comes down to the next step. So that -5, the -7, they both come down. 2/3 times x is 2/3 x. You could change that into a decimal like we did before. I wouldn't, because that's a repeating decimal. So I would just leave it like that. 2/3 times -9. Sorry, that's supposed to say times -9 equals -6. So we're going to write that next line as -6. So I distributed. Now I'm going to combine like terms. This has an x. That can't combine with these two, but those don't have x's. So those can combine to make -11. So I combine like terms there. Now I'm going to start solving it, which means I'm going to box that x term and deal with the thing that's on the outside of that box. I'm going to cancel out that -11 by adding 11 to both sides. The 2/3 x is going to be the only thing left on that side, because those cancel each other out, and that gives me a +4. I showed you 2 different ways you could solve this from here. We could divide by this as a decimal. Problem is it's a repeating decimal that goes on forever. I mean, it's not really a problem. You could do 4 divided by 0.6666. If you stop there, it's going to give you just a decimal, but if you keep going with it, I'm not sure how many you really need to type into decimals, but really this should be a whole number answer. If you want to do that, since that's multiplication, if you want to divide by that decimal, you can. You could also divide by it as a fraction. A lot of the times, though, you're going to see we multiply by the reciprocal. Any of these work. You could do either of these two, or what I'm going to teach you is that you multiply by this fraction flipped upside down. So we're going to multiply by 3/2 into both sides. Those cancel each other out, and that gives us that x is 6. I guess I also want to point out the instructions on each of these. The first 3 all said solve the equation. 4 says what's the value of x? That's the exact same question. It's just saying find the value of x that makes this true. Or what's the solution to the equation? All of those are asking us to do the same thing. Find the value of x that makes this equation true. All right, number 5 is the only one that's a different process. We don't have distributive property. And while we do have some like terms here, this is being divided by 4. We can't actually just put 18 together with this because 18 is involved in this division. You can't put that together with this 6 until you divide it. But to do that, you'd have to divide 4 into both of these. So actually, a simpler way to deal with this is boxing this entire thing and canceling the thing that's on the outside of that box. So I'm going to cancel out that +6 as my first step. So this entire fraction is going to come down into the next line. I subtracted the 6 away, so that's gone. And here I'm subtracting by 6 to get -4. Anytime you have an operation on top of a fraction, I would suggest that you cancel out this division. So right now we're dividing by 4. To cancel dividing by 4, we're going to multiply by 4. I also hope you hear the way I'm saying I suggest that you divide by 4. Sorry, you cancel out dividing by 4. You're allowed to do whatever you want to an equation. As long as you do the same thing on both sides, it's valid. You just have to be careful about the way you do that. I think this is just the easiest way to do this. So anytime I see a big fraction like this, I'm going to cancel out that fraction by doing the opposite of dividing by that number, which is multiplying by that number. So the big fraction goes away. It's just the stuff on top that's left over. And then we multiply by that same number on the other side. Now we're down to a 2-step equation. So we have this +5x I'm going to deal with that positive 18 as my next step. I'm going to subtract 18 from both sides. And then one last step. This is a pretty typical pattern. Your last two steps are either adding and subtracting, and then you divide away the coefficient here. We're going to divide by 5 on both sides. That's going to give us a decimal. That is negative 6.8. Alright, the last few are a model and a couple of word problems. So we're going to write an equation for this model, and then we're going to solve. So to start, I'm just going to count up what I have. I have 1, 2, 3, 4, 5 x's. So I have 5x plus 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Minus 12. Those are each minus blocks, so it's minus 12. And that equals, it's balanced with just 2 on the other side. So I'm going to combine like terms as my first step. I don't see any distributive property, so I combine like terms. That gives me 5x minus 9 equals 2. I'm going to box that 5x. Cancel out that minus 9 by adding 9 on both sides of that equal sign. That gives me 5x equals 11. And then one last step. I'm going to divide away that 5. So that gives me that x is 2.2. Alright, on number 7. Dante's property below is in the shape of a trapezoid. And it has these dimensions that are shown with these expressions. If the perimeter, or the distance around the shape, is 411, what's the value of x? Alright, so first I want to write that equation. Remember, the perimeter is just adding up these sides. That, plus that, plus that, plus that. And it's saying that that has a total of 411. So I'm adding these four sides together. X plus 27 plus this one plus x plus 74 plus this one, that's just an x, plus this last one, which is x plus 274, is adding up to a total of 411. So I don't have any distributive property, but I do have some combining like terms. I'm going to add the numbers together. Anything that's just a constant, I can put those together. That would give me 375. The 411 is just going to come down. And then I have 1, 2, 3, 4 x's that I can add together. That's 4x plus 375, which came from those constants. Now I have an equation I can solve. I'm going to box that and subtract 375 from both sides. That gives me 4x equals 36. And then I'm going to divide away that 4. So x equals 9. Last one. The parking garage charges $2.50 for the first hour, and then $3.50 for each additional hour. How many hours did Noah use the parking garage if he owes $27? Alright, so 27 is our total. I'm going to put that at the end of the equation to start. I want to think about how I could write these first two parts. $2.50 for the first hour. So it's going to be $2.50 plus some amount. And you might be thinking it's 3.5 times some number of hours, but the problem with that is that's saying it's all of the hours together. But we already got charged for the first hour. We don't want to get charged for that again. So we're going to take away the first hour from this amount. So it is $3.50 times something, but not just h. It's really going to be h minus 1. It's the number of hours after we take away that first hour. So I'm going to distribute first. So I get 2.5 plus 3.5h minus 3.5. I distributed that 3.5 into both of these. Now I can combine like terms. Just going to subtract 2.5 minus 3.5, that's negative 1. Whoops. That still equals 27. Add 1 to both sides. That gives us 3.5h equals 28. And then we'll divide by 3.5 on both sides. So we get that h, or the number of hours, is 8. So actually, we really didn't even need to do all that. We were told I didn't even read the second part of this, but we were actually told the solution already. We needed to come up with that equation, but that's our answer. It's 8. We would just want to know, what does that really represent? So Noah paid $8 to park in the garage. That's not really what this h represents. That's really saying how many hours. So it's not the amount of money. Actually, same thing here. That's labeling an amount of money. He didn't pay $8 for each additional hour. That's not talking about the amount that he paid. It's talking about the number of hours. It's not talking about when it closes. It's talking about how long he actually parked in the garage. All right, I hope this helps you with the U-Try.